B is the midpoint of MD. It wouldn't that be definition of midpoint? I would
It's also
assume.
given. It's also given. There can be more than one given.
Oh yeah.
Okay. Now, what you just referred to is the use of that. Like we have to use the fact that it's midpoint. It says here that M to B is equal to PD. These are congruent here. So that is because B is the midpoint of MD. So this leads to that. Okay, and that's
Yeah.
that's what you said, their definition of midpoint. Right. So where are they going? So sometimes it's clear where they're going. Then it's kind of like, well, I don't know where they're going. MB plus BD equals MB. Okay. So sometimes just go back and look like, okay, what's M to B, B to D equals M to D. So it's like part plus part equals
The whole thing.
so any idea what that is?
Well, it seems like they're adding the both parts in half to equal the full line from M to D.
Okay, so it includes the word addition. So one of the things I tell students when they're first learning this is even if you don't know what it is, try to put some words down like what you see, like they're adding. So maybe there's addition.
Yeah.
What
Okay.
how would you define MB and BD?
MB and BD. That would
Like what are they?
the I mean, would it if it's leading on from the last one, wouldn't
Nope,
that still
nope, nope, nope. What is M to be? Like M is a point. What
yeah,
is M to be?
a line,
Nope. Lines go on forever.
uh, array or segment?
Segment.
There you
So in
go.
this class, they're really specific, right?
Yeah.
Segment. So like you and I use line incorrectly when we're on the road. Like, oh, look at the line. It doesn't go on forever. It's
Yeah.
actually a segment, but potato, potato. So this is the segment addition postulate. It means that two segments add together to make the third segment.
Oh, okay.
Okay, so that's what I meant by like sometimes you just kind of piece together some words like, it's a segment. Let's just say it was array, ray, adding it together, ray, addition, segment addition. You're just, excuse me, you're trying to find something that works together there. So now I want you to focus on from 4 to 5. What's the same? What's different?
Well, they're both adding up and they're both equal MD. That's the sum.
These are the
But
same. These are the same. What's different?
the BD and MB,
Okay, so where could that come from?
the MB is the it's just a repeat of the
Okay,
first one.
so we don't use that word. What's a better word for repeat in math when you
Continuous or constant.
so yeah, I'll just give you the word. So substitution. So instead of replace or repeat, you're substituting.
Okay.
Substitution, property of equality or something.
So if there's a repeat or like they're using the same like one as before again, it's usually substitution.
They're literally putting instead of BD, they're putting MB in for BD.
Yeah. Okay, so it's substituting. Okay.
It's substitutes replacing, it's putting in for. Do you play sports?
Yeah.
What sport do you play?
Baseball.
Baseball. There's a pitching change, right? You go in, you're the pitcher, or you get replaced. That's what's going on here.
Yeah.
Or whatever. If you're out in the field, you can do a switch in the field too.
Mhm.
Good. All right. So how do you go from 5 to 6? They did switch sides. That's not a big deal. How'd they get 2 MB from MB plus MB?
Because 2 MB is from what is it? The segment equals what is it? The final one from M to D.
Right. But they're not, it says actually has nothing to do with segments. It's an algebraic property. Like why is X plus X 2X?
Because if that the X is added together equals 2X.
That's right. You're just adding addition property.
Yeah, okay.
of equality. Well, it's actually just addition property or simplify. I don't know. Depends on your teacher. Is your teacher pretty picky about stuff like this?
Usually yes.
Yeah. Look back at their notes, which I know you don't have a ton of time to do that. You always want to reuse the words that they use because they like them. So reuse what they have. Makes them feel
Got it.
good. Makes them feel really good about themselves. All right.
Okay.
Any questions on that before we move on to the other proof?
No, that makes a lot of sense.
All right. Line segment AB. This has probably been copied a few times. Intersects line segment MN at point P as shown in the diagram. Okay. If AP equals MP and NP equals BP, use the statements using the below to complete the proof that shows that AB equals MN. Okay. Sometimes it's good to have like a big picture, kind of like your game plan. You're playing sports. They're trying to tell you that we're hoping to prove that the whole segment here equals the length of the whole segment here by showing that since the two pieces are the same, that the whole thing must be the same because it's like I don't know, just me pick an analogy, but you break two things in half, and if the not half, but you break them apart, and if these are the same, those are the same, then the whole thing's the same. So
Yeah,
we're gonna work through it. Um, any idea why this is numbered 7, 8, 9, 10, 11, 12?
because it's just the spots you're supposed to fill in order. I
Okay,
think so. Like you
it's just
can, yeah,
weird. Okay, so what is the given in this problem?
that a line AP is equal to MP and NP is equal to BM or BP.
It looks like it's actually congruent. MP, I want to say segments, NP, congruent to BP. So it's good to label. It's label as you go. Don't label too much too soon. So AP congruent to MP and NP congruent to BP. Okay. So why is, and this is one of the weird things about geometry, like they're saying the segments are congruent, so they have the same length. The segments are congruent, so they have the same length.
Yeah.
And that's just something in geometry you have to do. It's not, you have to like one goes to the other. So like there's probably a formal way to say it, but the way that I usually tell students, it's like congruent segments have the same length.
Yes.
If your teacher doesn't like it, I don't know, give them what they want. Congruent segments have the same length. You can
Okay.
also use
Yes.
the same thing for angles. Congruent angles have the same angle measure. Congruent arcs have the same angle measure. It's like we know they're the same. It's like you got, whatever. Two baseball bats, they're exactly the same. You could say, okay, they're congruent, but do they have the same length? Yeah, they do.
Yeah.
All right. Segment addition postulate. Segment addition postulate. So MP plus NP equals AB. Okay. So I believe we're supposed to say here that like NP plus PM equals the whole thing. AP
Yeah.
plus PB equals the whole thing.
Yeah.
Hang on just a second. I'll be right back with you.
All right.
All right, I'm back. Um,
All
so
right.
we're going to say that AP plus PB equals AP.
Yeah. Okay.
And then I don't know if we need to say the other one. Probably should. NP plus PM equals NM. That's the segment addition postulate.
Yeah, okay.
So this is a little hard to, I mean, it's a little hard now to see, but the progression is they're saying that MP plus NP equals AB. They're saying that these two little pieces here equal the whole other piece because PB is really NP. AP. I got the letters are all messed up. It's just so hard
Yeah,
to
I
read.
see
I'm
it.
sorry.
'Cause no,
Yeah,
it's all
I
right.
think
Yeah,
that's I think
that
that's
one
what they're
came.
trying to say here. You basically switch the two of them. It's like, okay, these two equal the other one. So
Yeah.
to me, that's substitution.
Yeah, because if you're replacing it, it would be
Guess.
substitute.
I don't know. Let me look at this one more time. P B. I wrote the wrong thing here. I'm sorry. AP plus BB equals AB. No. So sorry. Sorry. We have to put that's what the issue is. We have to say that these are segments. That's why you have to put the lines on top. Then, okay, that's not quite correct. The substitutions come down here. They're now saying that MP plus NP equals AB. Now, what are they doing? I'm sorry, this is really hard to follow with the letters and all this. MP,
Yeah, I understand.
NP equals AB, MP plus PN equals MN, NP plus PN equals MN. That one seems, oh, I don't know. Really have no idea what they're going to do. But where they're leading to is that AP equals MN. That's these swapped in for each other. And then because they have the same length, they're now congruent, and that's not. I really don't follow what's going here, so we'll need to look at something else. I'll have to dig into this a little bit more, but it's generally the idea here. So,
Yeah.
do you have any other proofs that you want us to do, or do you want me to find some?
It would be helpful if we can find some because that's all the ones I have on my paper.
Okay. Now, do you know if you're going to emphasize more angles, line segments, triangle congruence proofs?
Most let's try triangle congruence proofs because I think that's going to be one mostly.
Okay. All right. So we're going to look at another proof here. This will be a little bit harder because it's not on your screen. I understand that. Just do the best you can. I would recommend redrawing the figure. You can. That's at least will help a little bit.
Yeah.
All right. So we got these two triangles. We're trying to prove are congruent. We know that VE bisects angle DEF. Okay. So that's given.
Yeah, because the first always given.
Yeah. Now it's not always the case that all the givens come together. You see here, there's a second given that's here.
Yeah.
Okay. Now angle DEG. Okay, so GE bisects DEF. That what this is leading to this one here, that angle DEG, which is this angle here that I'm drawing a little arc on, it's congruent to FEG. Here's the other one. That comes from this, and the reason is basically the wording that's in that statement. So since the segment bisects the angles are congruent, could you try to formulate words that could mean that? The reason? Yes, no, maybe. What are we bisecting? Maybe you're muted. Oh, you're lost. You dropped out. Okay.
Can you? Does it reach?
Hey, Alec, are you there?
Uh, yes, I'm
Okay.
sorry. My Zoom
That's,
crashed.
that's okay. It does happen. Let me know if you can see my screen.
Yes, I can.
Excellent. Okay, so we hadn't really done much. I'll just kind of reiterate that the givens don't necessarily have to come in order on your proofs. They were, but they don't have to. We're discussing this idea that segment GE bisects angle DEF, which makes these angles congruent. That's what this leads to, but what's the reason? It's based on what's said here. Could you try to formulate that for us, please?
Uh, the reason why
What?
the reason why GE
No,
bisects
no.
DE.
That's given. The reason why the angles are congruent comes from the fact that it's bisected. What kind of words go there?
Wouldn't it be like reflexive property since G is in the middle
So
between both of them?
so your go-to is always definition of.
Picture definition of congruence,
Nope. What are you doing in number one? What is this word here?
bisects,
And what are you bisecting?
GE.
An angle.
Oh,
Definition of angle bisector.
definition of angle bisector. Okay.
You've got to switch your thinking to, you're very specific right now. You want to become more macro, big picture, segment, bisect, angle, angle, congruent, angle.
Okay.
Okay. So now we also know that angle D is congruent to angle F. Okay. Now, the next thing it says there's GE congruent to GE. You already mentioned why this is. Could you just say what you said about 60 seconds ago?
That they're both they're in a segment.
So why are they congruent? You said it though. It's like when you look in the mirror, why you see yourself.
Reflection because it's in
Reflexive,
between.
reflection, reflexive, it's fine.
Prop.
It's
Yeah.
reflexive property, yeah. Okay. Now, there are 5 ways to prove triangles are congruent. This is one of them. Do you remember any of the 5 besides AAS? Prove triangle congruence?
Yeah, I remember it. It was SSFAS, ASA, AAS.
Didn't hear SAS, maybe you said that. The 5th one is hypotenuse leg. It only applies to right triangles. Okay. The questions on that? You do need to know this. This is, your responsibility to write down, remember?
Yeah.
Okay. I mentioned this to your mom. The proof tend to go away after the first semester. If you really like them, there's entire classes in college where all you do are proofs. So we have that to look forward to. All right, go ahead. Take a look at this one here. You'll notice that in the second to last line, we're proving triangles are congruent. So we're going to use one of those 5 that I mentioned here. We don't know which one yet, but now it is almost always the case that when you're proving an angle or a side, okay, that you're going to first prove the triangles are congruent, and that leads to the angle or the side being congruent. You remember doing some of those in class like that?
Yeah, I think so.
Okay. You remember CP, CTC?
Yes.
Okay. So that always follows from triangles being congruent. Next line is almost always CP, CTC. Because you're saying corresponding parts are congruent, triangles are congruent. That's how you get the angle or the side here. That's congruent.
Okay, got it.
All right. And then the reason for the first one is given. Okay.
Mhm.
And it'd be a good idea to go to the drawing and label. So AD congruent to BC, CB, B to A to C. So here's what I'm going to do here. I'm going to label, I'll use little letters here. X, Y, Z, P, Q, R. Can you tell me which of those is DAC, please?
DAC. That's what is it? Y. That's Y, A, X.
I'm looking for the little letter. Is it X, Y, Z, P, Q, R, DAC?
It would be Y, Y, Z, X.
Just a single letter. I'm looking for just a single letter. I think you understand, but when I hear something different than I'm hearing.
Oh, Y.
Okay. So I'm gonna try this one more time. So here are 3 letters A, B, C. This is angle A, B, C. The middle letter is the vertex. It could also
Oh,
be angle CBA. Anything
yeah,
else
but
is
the
wrong. So the
okay, yeah,
middle letter has to be the vertex. So why don't you try this one more time. Which of these letters is DAC?
it's Z.
It is Z. Okay. Which is BCA.
Is it BCA? That's R. No, that's
Good.
X.
That good.
No, it's
That's good. You had it. You had it right. Okay. Very good. All right. So why is DAC congruent to BCA? No idea. Oh, because the measure. So again, you got to go back to the previous line. The measure of the angles is they have the same angle. They're saying the angle measures are the same, so therefore the angles are congruent. It's kind of like the lengths. It's congruent, so they have the same lengths.
yeah.
So the reason here has to have some wording about congruence, angles, same measure, same length, or same congruent, so they have the same measure, or they're the same measure, so they are congruent. So if that's not clear, what I'm trying to get you to say here is something about angles with the same measure.
Are also congruent.
Exactly. Yeah. Okay. You don't need to put in extra words. You just need to have the, sort of the right direction there. All right. Now this right here, AD congruent to BC, you're looking for these sort of paths. Like, okay, I know that, so at least to that. So if the segments are the same, why are they congruent? They have the same length. Why are they congruent?
Because they also are the same angle.
We're talking about segments this time, though.
Oh, because they're the same length,
Okay, so they're the same length means that they are.
congruent,
So you say segments, same length
or
are congruent. Like the distance from home plate to first is the same as third to home. I believe. I don't know that it's changed, but if they're the same length, then they're congruent. All right. We did this in a previous problem. Why is AC congruent to AC? What is the reason?
reflexive.
Yeah, reflexive property. And then always good to label that in the drawing as you go. Don't wait till the end. All right. And then you've got 5 options for why the triangles are congruent. You've got an angle and 2 sides.
So
So
an angle,
again,
so an angle of two sides, wouldn't that be? Wait,
so which of those 4 is it? Sometimes it's process of elimination.
side angle side.
It is side angle side.
All right.
Give me some feedback. What are you thinking right now?
Well, I feel like I'm starting to understand it a lot more. I was able to understand. I'm starting to understand the side angle sides a lot more than I did before, along with reflexive. But the little thing that's confusing, if I hope you can explain, is when I have to decide of when to write a full sentence, like angles. What is it? Segments are same length or congruent. Like when do I have to use those sentences?
Yeah, I
Then
mean it's like if I had been working with you for a while and we got to the notes, I could tell you really want to like think real hard about what your teacher wants. I don't know the answer. Like there are like some books. I mean, here's how it used to be when I was a student. Sounds really archaic. It was like theorem 12.1, 12.2. It's like I don't, I mean, they've done better now, but it depends on the teacher. Like and this isn't even correct. Like it's supposed to be side angle, side postulate, or theorem or something. I'm
yeah,
not big on. I mean, I don't like proofs, truthfully. Like I took a lot of classes with proofs and never really thought that they were useful. I did more applied math, so I don't have the best answer for you. Um, you've got to be careful not to write too much. When they grade, they're looking for keywords. They're not reading the entire sentence. They're reading for the keywords like angle, segment, congruent, side, something like that.
Okay.
Okay, so this is an easier proof than any that we've done, but none of the statements and reasons are given. So we're going to look at this next because it's a little bit more challenging. Tell me what to write first, please.
You would write your statement. So angle B is congruent to angle D.
And let's for a moment presume that they're both in I'm not sure. So we'll just do that. Given. All right. And they're already labeled in there. Now, the reason they're using a single letter is because there's no confusion. Like B can only refer to this angle, D can only refer to this angle. But if I put like a dot here and you said angle C, I don't know whether it's the dot where my cursor is, where the C is below there. You have to be very careful.
Yeah, I want to say it's the middle where they intersect for C.
So we're not going to do that. So we were trying to prove that the triangles are congruent. There's not much more to do here, but you don't have enough currently. But there is something else. Anything stand out to you in this drawing on the right that's congruent?
The line AC looks like it's congruent to a line CE or
That's
EC.
already stated. Yeah, it's already there.
Oh, my bad.
So think about when things meet at an X. What do you remember about that?
That all lengths or like all lines that form the X are congruent to each other.
Let's presume they go on forever. So we're not talking about the lines. What about the angles? What do you know about the angles?
That they are they're congruent or
Yes.
they all
Yes. Okay. All right. So give me the three letters that define the blue angle.
A B C.
That's this one right here. Middle letter has to be the vertex. Middle letter is C.
Oh, so ACB.
That works. So angle ACB is congruent to, give me the three letters that make up the red angle, the red dot there.
BCE.
BCE. And you said it vertical angles are, what's the last word? What did we say here?
Congruent.
Yeah. Now, I mean, okay. So full disclosure, you're probably supposed to say that ACB and DCE are vertical angles, and then you're supposed to say they're congruent. I don't know what your instructor wants. This is probably better than where you've been, but like kind of supposed to like say that they're vertical and then show that they're congruent. But that's a little nuanced thing. I wouldn't super worry about it at this point. I don't really know if they just added an extra line here, or maybe the other given was supposed to go another line. I don't know. There's stuff like that. Keep in mind here. So we know that the angles are congruent. Do we know enough to prove that the triangles are congruent? And if so, what are we going to use? Which of these is it? It's your responsibility to remember those and get those down.
Yeah, wouldn't it be side angle side again?
So SAS requires the angle to be between the sides. Is that the case? I only see that you have one side in each triangle. Side and side. Angle and angle. Angle and angle.
Oh, so would it be angle side?
Yes. So just to be clear, side angle side, side angle side. Angle side angle. Angle side angle. Side has to be between the angle has to be between the sides.
Yeah, and do we have to start with the vertex when we're, what is it? Trying to identify which one's which?
No, it's a path. It's a path. Okay. Like, I mean, you could think of it as like, rounding first, second. I mean, it's a direction. It's not willy-nilly. It's, it's a flow.
Yeah, but where's the flow start usually?
Depends on which one it is. So the letter tells you though, like SAS means it starts with a side to an angle to a side. ASA, angle to a side to an angle.
Yeah, okay.
You sure that's clear?
Uh, a little. Like if we're trying
It's
to
okay to
figure
say
out,
no. Yeah.
if we're trying to see which one's like SAS or ASS, like where do we like start on the figure, like the actual thing to
Okay,
like
so there is no ASS. You got to be careful with that one.
um
Yeah,
but
what I'm
like
trying to get you to see is that like the angle is between the sides. The side is between the angles. SAS has two sides and an angle. Angle side angle is two angles and a side. Now, what you might be confusing is ASA and AAS. So let me draw these slightly differently. I think that's what you're really asking. So let me try to clarify that. This is angle, side, angle. This is the side between the two congruent angles.
yeah, okay.
This is angle, angle, side. There's a path. Now, to answer your question, your follow-up question, which might be, well, what if I wanted to start here? Angle to angle. Well, what do you know about this side? Nothing.
No,
Moment.
yeah,
Now, in another drawing, though, here's what could be in another drawing. Angle, angle, side, then it's okay. That's okay.
okay,
So
yeah,
you're skipping this side, get to that side over there.
okay, okay. That makes sense.
I'm guessing this was never explained in class.
No, not really.
That's brutal. Okay. All right. Is this okay? Just doing more of these, or you got something else in mind? Is this okay?
Yeah.
And by the way, I don't find these exciting. Like this isn't interesting, but we got to do it. So,
Yeah.
okay. So, given angle PGJ, you're going to angle SGJ, PGJ. Okay, so that's this one up here. It's congruent to SGJ. That's there. Is that okay?
Yeah.
All right. VJ perpendicular to PS. So that's why this 90 degree is written there.
Yeah.
Okay. Now we're going to put in that angle P is congruent to angle S down here at the bottom. Typically, you prove an angle or side after proving triangle congruence, which is CP CTC. Is that okay?
Yeah.
All right, so we're probably going to prove the triangles are congruent at that moment. All right, so it's a right triangle, which means you can possibly use hypotenuse leg, okay? Possibly. But that requires the hypotenuse to be congruent. That requires GP to be congruent to GS. Do you see anything about that in here?
No.
The only time you typically use something like that is if you knew the triangle was isosceles. Then you would know that the outer segments are congruent. Are they isosceles? No.
Uh, mm, Yeah.
We don't know. No, we don't know that. No. You cannot assume.
Yeah, you're
Very
right.
dangerous. Okay. So what can we do? Well, we can use the given. Now, when you've got a given angle or a side congruent, you don't do anything with that. But the perpendicular, we're going to do something with. What do you remember about the perpendicular?
The it for this angle, it being perpendicular, it's forming a right angle.
Okay. Anything else you remember?
Not much.
Okay. I remember this proof. Um, okay. Do you see anything else that's congruent in this drawing?
Uh, I would say that lines GP to G and GS are congruent.
Okay, that you can't use that. Good try. There is something else here that we used in the previous proof. Is there anything that's shared between the two?
Uh, the G and J, G to J.
Yes. Okay, so we're going to use that. Now it's not drawn, but what is the angle measure? Kind of where my dot is here. It's the angle measure there.
Right angle.
And what do you know about right angles?
They're 90 degrees.
Anything else?
They have both
Both
add up
90
to.
degrees. Yeah. They're both 90 degrees. Are they congruent?
Yeah.
Good. Yeah, good. Okay. So we've got an angle, we've got a side, we've got an angle. Is that enough to prove the triangle?
Yes, for
So
AS.
that's another way to do the proofs is you kind of step through it before you write anything down. You're like, all right, well, I think that's congruent. Okay, those are congruent. All right, yes, it's an angle, it's an angle. All right, I got it. Then you got to start filling stuff in. It's another way to go. Okay, since GJ is perpendicular to PS, what kind of angles are they? You've already said it. What kind of angles are these?
90-degree angles.
They're right angles. You have to say that. You have to say angle GJS, comma, angle GJP are right angles. Now, the reason, that's the hard part. The reason is always the hard part. It comes from this right here, GJ perpendicular to that. So what do you think word should also appear in the reason?
The perpendicular.
Perpendicular. So I'll let you know that. Okay. Anything else you can think of?
No.
Okay. So if you have no idea, you can just say perpendicular lines meet at right angle. Or you can say definition of perpendicular segments. So that definition of is a good one if you're really stuck. It kind of looks good, right? Definition of,
Yeah.
right? Okay, so have we said that they're congruent though?
No.
Nope. It's like same up there. They're both not right angles. So you can say the measure of angle EJS equals the measure of angle EJP equals 90 degrees. Why is that? Why are right angles 90 degrees?
Because it's a straight angle or adds up to 180.
We don't know that yet.
No.
Definition of, what are we calling them?
Congruent angles.
Right
Right.
angles. You will often find that you're reusing the word here in this. Now we can say that the angles are congruent. Angle GJS congruent to angle GJP. Why are they congruent? Well, they
90
both have
degrees.
the same measure.
Yeah.
What do you mean that?
That the same measurements are congruent.
Same angle measure, they're congruent. Okay, perfect. All right. Now, he mentioned that GJ is congruent to GJ,
reflexive.
reflexive property. Okay, now the triangles are congruent. We haven't done much with this, but the letter order matters. Okay, it's not arbitrary. You can't just pick 3 letters. It's a path. Okay, so
Yes.
let me draw a path. V, the J, the P, and back. That's a path. What is the equivalent path for the other triangle?
G to J to S.
Exactly. It's a path. So when you give me the triangle letters, which you're about to do, make sure you give me in that path, please, or a path that is consistent.
Well, G J P is congruent to G J S.
Very good. And what's the reason? Why are the triangles congruent?
Because they're the same angles.
We can only use these 5.
Oh,
Which of those are we using?
side, side, side. Oh no,
We don't
side,
have,
angle side.
so I kind of covered it up. We said it earlier, we had an angle,
Oh,
side, and an
ASI.
angle. I would say. Okay. There is hope. Like you would get this with a few more lessons. You would really understand this, and it wouldn't be that difficult. And you would say, "Oh, I can do this." I don't know that
Yeah,
you're there yet, but
I would say I know a lot more than I did starting, which is
yes.